All right, so apologies, this got cut off. It says two cars are driving away from an intersection in perpendicular directions. The first car's velocity is 5 meters per second, and the second car's velocity is 8 meters per second. At a certain instant, the first car is 15 meters from the intersection, and the second is 20 meters from the intersection. And we have to find what the rate of change of the distance between the cars at that instant is. So first, like, we gotta draw this picture. So let's make our intersection. Here's our intersection, we'll say. And it says the first car is driving at 5 meters per second. So they're just moving away from each other. We don't really need we don't need to know what direction necessarily. So let's just say the first car is moving this way. Let's say it's moving east. So this is car one. So car one's going this way. Okay, and so like I'm gonna put a point here. What you want to do is indicate a variable here. Like this length here is, if the car's moving that way, that length is changing. Let's call that length A. Okay, so that's changing. And it's changing at exactly the same, it's increasing at exactly the speed that the car's velocity is, right? Like if the car's going 5 meters per second, then this length is increasing at 5 meters per second. So I'm just going to write, we know dA dt is equal to 5. And then we also have a car moving in in a perpendicular direction, the other car. So that's going 8 meters per second. So let's just change that to, this is a variable, that point there is the, where the car is now. And so like we also know dB dt is whatever the rate of the car is, and that is 8 meters per second. Guess I should put the units there. So so there we are. And so like now what do we want? We want the rate of change of the distance between them. So we'll call this C. Good old Pythagorean theorem labels. And like when do we want that? So we want dc dt, and let's kind of scroll down here. We want dc dt at an instant, and like what's characterizing this instant? So when the first car is 15 meters. Okay, so the first car is A, so it's when A is 15, right? When that distance is 15. So when A is equal to 15, and it's when the second car is 20 meters. So the second car being 20 meters translates in our diagram to B being 20. And so now we just need a relationship between A, B, and C. Well, that's just the Pythagorean theorem. So A squared plus B squared is equal to C squared. We differentiate both sides with respect to time. So we get 2A times dA dt plus 2B times dB dt is equal to 2C times dc dt. We do not expect this to turn into a number because that's what we're looking for, but everything else should turn into a number so that we can solve for that. You might divide everything by 2. I mean, if this is multiple choice, just do that like that. A at this moment is 15, so this becomes 15. dA dt we learned is 5, if we look above. B is 20, dB dt is 8, and C, so we don't know C at this point, right? How are we going to find C? Well, at this moment, our triangle looks like this. So this is like at the moment in question. A is 15, B is 20, and so the Pythagorean theorem gives us what C is. So I'll just kind of go off to the side here. C squared is equal to 20 squared plus 15 squared. So C squared is 400 plus, I think 15 squared is 225. Yeah, 225. So then C squared is equal to 625, and I recognize that as 25 squared. So that's, C is 25. So at that moment we can solve for C, and then dc dt is what we're looking for. All right, so I'll just plow through the arithmetic. 15 times 5 is 50 is 75 plus 160 equals 25 times dc dt. So that means that, let's see, 160 plus 75, and then divide that by 25, I get 9.4. Well, that is 235 divided by 25, 9.4. 9.4 meters per second, so that answer is B.